Hello, everybody. So once again, this time of the semester, I like to try to keep the lecture somewhat short. I have two things to go over. The first one will go quickly because it's something that seems kind of obvious, but when you start looking at reference material, yeah, I guess the intro for both of them involves reference material. So first one, when you start looking at reference material, you'll see some strange things. And like, why are they doing that in this weird roundabout way? So I'm going to talk about some of that. That it's basically writing files, and there's an easy way to do it and better ways to do it. And a lot of times you'll, like in reference material, or you might come across something that you think, you start to wonder why they're doing one of the better ways instead of the easy way. So I at least want to cover that. The second thing has to do with the fact that in the modern world, we're probably going to run our Java applications on the web, across the web, on servers, not on local desktops. Java is for big things. That goes a lot better on a server, where it can service lots and lots of people instead of the one person sitting in front of a desktop or laptop. But we saw JSP, Java Server pages, and we'll look at those a couple more times. But we don't always need all that HTML. Sometimes we just need the data. Right? We just need the stuff the server does, and we don't need to format it nicely on a web page. We just need what the server is going to get for us. In that case, we can use servlets where it does server operations. Fairly short talking about that. Mostly it's going to be talking about CRUD. Most of y'all have probably heard of CRUD. If not, we'll talk about what that means. The things servers do: copy, request, update, delete. It's pretty much what a server does. CRUD. Then the thing about servlets, I'll try to remember to make a note about like where it's at in the timestamps. You all can jot down the time or something, because about 2 years ago they changed it. And what used to be an XML file with 100 lines, or up to about 100 lines, I guess we could have got rid of some of them, some of the redundancies and error handling and things, but it really, I'll just go with the number 100 lines, and 99 of them were copy and paste from the previous time you did it. So there's only one line that got changed. And about 2 years ago, they finally switched Java around, so that's handled with an annotation now. But as I was looking around, it looks like all the reference material and tutorials, at least the ones that score high for the Google search bot, one of the things is how many people have rated that forum post well, or liked the forum post, or gave a thumbs up to a YouTube tutorial. That's one of the things the bots look at. So I guess the new ones might not be scoring high or something, but all the tutorials are still doing the old way. And the new way is just a simple annotation. So I wanted to make sure and make a big deal out of that. And I'll try to remember to comment where it is in the timestamp, but it's an annotation. It's like a comment. We put at, and then a couple keywords right before our method. So it's not like it's something hard, but even though it's been around, even though that's been the way to do it in the Java language for 2 years now, it doesn't seem to be showing up in the reference material and tutorials unless we go to the actual official Java docs, which I stress that in the classroom, but documentation is hard to read. It's usually a lot easier if we just need to remember some syntax or something to open up the tutorial and skip to the middle of the YouTube video or something so we can see some written code and remember that syntax. But we're all a little bit different. We're all unique individuals, so whatever works best for you. That's part of what you want to look for in a class. Try different things. See what works best. But remember to refer back to the official documentation, because that is the user manual, and that will get updated with the language. Whereas other things will go out of date. So our first topic for tonight. So we can finish this up, and there's plenty of time to work on things, maybe for this class. Oh yeah, there is the final this week. Remember, the final is due before the break. Well, most people are going to count the break starting on a Friday, but I believe you have till Sunday to do the final, but let's still go ahead and say before the break. And then the homework isn't due until after the break. It's still on the normal schedule. So the homework is still what, a week and a half away. Oh, yes, midterm, sorry, not final. I'm used to 8 week, all the other classes are ending this week. All the other classes have finals. Midterm this week, thank you, Dallas. The midterm is due before the break. And then after we get back is when the homework is due. So make sure you get that. Make sure you don't overlook that. And I assume most people have other classes, so you might have some work there you need to catch up on. Those people that only take one class at a time is usually because they have jobs and lots of other things in their life, so they're very, very busy. They actually use a little bit extra time. So around this time of this semester, I try to back off a little bit on lecture time, kind of like we did last week. Thursday, I have an example in mind, so it'll probably be closer to 2 hours, but a full example where we look all the stuff we've looked at for the last 3 weeks, I think, go into one situational thing where we're developing an algorithm and putting it in place instead of just random syntax examples. I didn't want to see that because some of it makes a lot more sense when we see it in action instead of just the syntax for it. So a text file is pretty much just like console and out. I'll write that. Text file is pretty much whoops, just like console output. We're just sending the stuff, strings we would have sent to the console, we send to a text file instead. Pretty straightforward. There's an analogy I like to use that there's a subtlety in the way things are presented, and we work with file handlers in all of our languages. So in some along the way, you may have heard other things, start writing files and they keep talking about the file in the programming language. But a file is something in storage. File never actually comes in data or comes into RAM. The data from the file can come into RAM, usually not the entire file, right? Because the entire file in storage is quite often bigger than RAM. It would use up all our RAM, and other software trying to use our random access memory would get bogged down because we read a whole file in at a time. So a file is something in storage, and in programming, we work with file handlers. The analogy I like to think of is like the old reel-to-reel tape machines. A long time ago, you all have probably seen them in history books or something. But magnetic tape, we'd have two big reels of tape with iron filing shavings, basically like sawdust, only iron instead of wood, in between two pieces of Scotch tape. Like that really was how they invented it. They stretched out a piece of Scotch tape and stuck it down on a pile of iron filings, and then stuck that on another piece of Scotch tape so that it stuck together, and it worked. And then modified it a little bit, not much from the original two pieces of Scotch tape with iron in between them. And it rolls past two magnets, moving from one reel to another reel. We can segment it out sort of spatially, and then each little segment represents a bit per se. And then there are two magnets that it rolls past. They obviously wouldn't look like this, but the standard graphical representation of a magnet. So we have two magnets, and one of those is held stiff. It does not move. And the other one is on a spring. So it bounces up and down. And then those would just go off to our actual processing in RAM. And back in the day, that was the big vacuum tubes. The heat producing things, heating coils, and amplification, and all that stuff we needed. And if we want to read the file, we use the one on the spring. Because then our magnetic I'll write first. So the one that's held stationary is a write one. So I'll talk about writing the data first. That way I get some symbols up there. So that's held stiff. So as the tape rolls past, it's going to change the magnetic field of those iron shavings. It's going to align them one way or another. Everybody's seen a magnet before, right? If you put a little iron powder next to that magnet, it's going to move pretty quick. Obviously not every single one, but once it's past 50%, there's clearly some polarity to it. So we'd end up with a bunch of north and south poles. North, south, south. We could represent a binary state. So we can turn that back into ones and zeros, depending on how the machine's wired up. So we hold the magnet stiff, and that changes all that polarity. This is a bunch of north and south poles are ones and zeros. Or for our read head, when we want to read it, we have another magnet on a spring, so that as those segments of tape roll past with some polarity, they push that other magnet up and down. They either attract it or repel it. And from that, we can detect what that's doing on the spring. So that's how those work. But there's an important distinction that's easy to see with those old mechanical systems, because our processing's over here. It's going to feed right into our RAM and then have the CPU attached to that. And we do all our processing over there. The tape itself is our file. So the data itself never actually makes it over to RAM, only a copy of it. And in between, we have this piece that can interact with our data. So it upgraded to a virtual version, but what we really have is file handlers. That's the word we used once it was all virtually. So you might see in reference material where it's talking about programming, it says something about a file. And there's a slight distinction that a lot of times does not matter. You can talk about it as a file or the data in the file. It's two separate things, but every once in a while that distinction does show up. So I wanted to take a moment and remind you that what we work with are file handlers. We never work with the file directly because the file is in storage and our program is in RAM. So they're in two separate places. And the handler is basically the piece that can see our data. It's like those little magnetic heads. It either changes what our data is, or it bounces up and down in response to it. It's easier to visualize the separation there as opposed to when it's all internal to the machine. That's why I go back to that old picture. But it's basically that is what we would have seen. You would have seen in the two prereqs to this at the minimum. Working with the file handler, we create a new file handler. We send a string to it, puts that in a text file. So kind of a similar thing. We'll use objects though, sort of customized objects. And so we have a file object. I'll go ahead and write a new file. So we have this new file object, and that has the path. And we can use the path in other ways, but it's usually not the best idea to use that file in other ways, or to use just the string, because the file object will have other things with it. I'm going to just pull up the documentation real quick and point at some of the methods. This part's going to go quick, and it'll be let you all kind of practice with it. File object, Java, JavaScript, Java. I don't know why that popped up in Google. There's not file objects in JavaScript. That's one place where we definitely don't want to have write access. So you can see there's quite a bit there. Some constructors, but the main thing are these methods down here. So it's an executable file, or readable, writable, and all these different controls that we would expect with the file already built into it. So we don't have to manually do that stuff later. Get an absolute file. So we can get the absolute file name, the path to the file. We can pull the name. Oops, didn't mean to click there. We can pull the name out of the file path. We can access the directory it's in, and all that stuff that would be associated with the file is already built in. That we definitely do not have if we work with the string directly. So always a better idea to do that. Y'all can look at the documentation there. That's definitely something to definitely something you're going to work with. But we take that file object, and then that feeds into a scanner object. And just like when we read, or for reading, when we read input from the console, our scanner can do that. It's console input is coming from keyboard, it's Unicode. So the scanner is set up to read 16 bits at a time. And then we just read 16 bits at a time, whatever's in that file. So that's kind of assuming it's a text file. How many of our data types are 16 bits? Should be thinking 2, right? Shorts, short integers, and characters. Otherwise, we have lots of different sizes of data types. So that was the main thing I wanted to talk about, is the size. So the next thing I was going to write up here is sort of the same thing. To go the other way, we could create a new print writer object. So a new print writer object that feeds things into another new file object. And then those two things work like a console output that we're used to. This has the same methods as your standard output, the std.out, or for Java system.out.something. We have the same thing with the print writer. So print writer.println.print.printf. And all those different print options that we have with the system, we've seen with system.out repeatedly. The same ones here. So a lot of people also like to use this when it's not text output. Whatever we have, we just feed it into a print writer object, and then we can act like we're sending it to the console and we don't have to remember a whole bunch of different methods. Some people like that, but again, it's the same things we were doing on the console output, we're just doing it with the file. And it's going to assume text file, kind of like console output, which means 16 bits everywhere. I'll write 16 bits over here by the scanner. That's the easiest place to see it, 16 bits. So if we want to transfer our data 16 bits at a time, and we know 16 bits at a time will be fine, then the scanner is probably the way to go. But usually our data is not going to break down into just 16 bits. So we can do better. I'm going to erase the picture. A very old thing, but there's physical pieces, so it's easier to visualize the difference between the file and the file handler with the old mechanical systems. Hopefully everybody's at least seen that in a museum or history book or something. Everything in these notes. Read with the scanner, write with the print writer. And notice it's the same type of file object. So if you were reading from a file, you'd create the new file object, assign that to some variable so you can refer to it in more than one spot. Oh. Okay. I'm glad that, and Chatham said that was helpful. I'm glad that was helpful. Because that's what we're here for. So we can save this to a reference. New file equals F. And if we want to rewrite to it, we just pass that into the print writer object constructor. So we can use that same file to go back and forth. We'll see that in an example, and that's probably what we're going to do in classroom examples over and over again because it's a lot easier. But we can do better. Unicode 16 bits at a time. Oh, I did have another note I want to make that I'll write in green or blue, maybe. To tie into what we were talking about last week, our scanner will throw a file not found exception. So this one has to be wrapped in a try-catch block. If it's not the system input, we have to put a scanner inside a try-catch block. The file, we can reference that outside of the try-catch block. And that throws a lot of people off because we're thinking, okay, new file, that's going to throw a file not found exception. But a new file is just sort of a reference to it. That's like directions for the handler. It's like, look over there. It has the name, the file path, the parent directories, and all that other information. So it's telling the scanner where to look. So it's actually the scanner that throws that exception. To tie into what we were talking about last week. And a print writer throws an IO exception. Both capital, yeah. IO exception. So if we want to do those big long chains of try-catch blocks, like your textbook probably has a few places where you get very specific. Those would be the two you would need for just a basic text file, which on your way through school, a basic text file is probably what you want to use over and over again. But not always. Like I said, there was two things on the list to talk about tonight: file IO and servlets. When we're getting stuff from a server, is 16 bits going to cut it from a server? Probably not, but we usually do transfer to and from a server with Unicode. The two most popular, XML and JSON. Actually, at some point later this semester, we'll probably look at the fine-grained details of when one is better than the other. But in general, the program is going to write that code, so we don't have to worry about syntax or anything, or typing all those tags or curly braces or missing semicolons. We don't have to worry about that ourselves, except for the first time when we're writing the file and debugging it. We'll look at the reasons we would want to use that, other than one's easier to type than the other. Because we don't manually type those. But that 16 bits might be a bit of a problem. We also have another thing here. Black marker. So another thing we can throw in there to work with is some sort of stream. And that's part of the reason the next lecture is going to be shorter tonight. Instead of a file in one of these things, we can throw streams in. And we aren't really going to look at streams like ready to do homework with them until week 8. So once we've seen streams, some of this will make more sense. For now, it's just a big long word in the object names we have to type. But we'll see what's really happening in a stream in a couple weeks. But we need them tonight. So a big improvement will be a file input stream or a file output stream. And I'm guessing y'all can quickly figure out which one goes where on those two lists. File input and output stream. And similar to a scanner or print writer, a scanner or print writer, I'm just going to abbreviate it here. But it creates a binary file one byte at a time. One byte at a time. So it's going to align to our data a lot better. Because all of our data sizes, we have a bunch of them, but they're all divisible by 8, right? They're not just divisible by 2, because they're binary numbers. If you don't believe me, go look at that list again. All of our data types are divisible by 8. So 1 byte is going to work out a lot better than 2 bytes. 2 bytes is great for Unicode because we know Unicode is always going to be 2 bytes, 16 bits each. But doing it 8 bits at a time works out a lot better. However, if we're doing it 8 bits at a time, Unicode is not 8 bits. So keep in mind that that may not be readable as a text file. So more for our object stuff. Right? We have more than text that we're working with. Whenever we have integers, we have to turn those into text, right? Everybody do that in your 120 class? Our integers, basic numbers 0 through 9, are digits. If we want those as text, we have to turn those into ASCII or Unicode values 48 through 57. Is that right? Yeah, 57, I think. 48 0. But we have to add 48 to get to that. Or maybe you had an assignment where you went the other way. You were given an ASCII character and you need to turn that back into a number. So you subtract off the ASCII code, change the symbols into a number. Different things we can do. But if we're working with bytes, the computer might not register it as pure Unicode. So be aware of that. Along with those, oh yeah, and just to be clear, in the constructor, we pass in a file object. So that's where it's similar to these. So instead of passing our file object into a scanner, we pass our file object into a string. Or vice versa, if we're going the other way, instead of passing it into a print operator object, we pass the file object into the output string. And there's more than just file in and out. We also have object in and out, object input stream, and object output stream. And those are really, really useful for like save buttons. Because if we're going to save a file, whatever our software is doing, we don't necessarily need it in human readable form. For example, is a Word document in human readable form? I see some like questioning looks of uncertainty. So let's look, right? That's how we learn. We ask questions and then figure out the answer to them. The scientific method, we have a question. Well, that's a question we can conduct a quick experiment to answer. I have Word on this computer. Here's a Word document. I'll save that. Oh, not on OneDrive. If anybody hasn't, what is up with the save there? Oh, more locations down there. If anybody hasn't encountered it yet, when you upgrade to Windows 11, it will try to do OneDrive, and you have to actually go into the registry and tell it you want to use the local file system, not OneDrive. So if you hit a problem with that, let me know. I can help you get to that spot in the registry. And once you get there, then it's just type the local file path instead of the URL. Oh, I don't like this. Word doc. So there's a Word document. And this is how we learn, right? That learning process. We had a question. Let's look for our answer. Open that with limited options. Word notepad. So by human readable, we should be able to open it in our most basic text editor and recognize what's going on. I can't read that. So no, a Word document, even though there's text in there, is not human readable. Y'all may have encountered that before. Has anybody ever had like code you copied and pasted from a Word document and then suddenly your whole program crashed and you couldn't get it back? That was most likely quotation marks. But Microsoft Word and Google Docs and whatever the writer in LibreOffice is and Pages, they do not use Unicode. And one of the biggest problems is those quotation marks, those fancy quote marks that turn towards the words. Those are not in Unicode. We have lots and lots of symbols, but apparently those aren't one of them. And then when you open it someplace where you can edit code, it can't show the actual thing, so it shows arbitrary symbols. Sometimes it will. Some editors will show quote marks there at least, but that's not what's on the inside. So it causes problems to copy scripts in a Word document over and try to turn in the code. So a quick pass of the learning process. I don't see anything readable in here. Oh, docprops.core.xml. There's something readable. I definitely don't see the words I typed in here. I don't see the words here are a word. Here is a Word document anywhere. So there's the answer to that question. Not human readable form when we save it. It's still in the Microsoft Word object form where layers and layers of parent, child classes, paragraphs goes to the top. Documents are parents of pages. Pages are parents of paragraphs. Paragraphs are parents of words, I think. It might be sentences in there as well. But then we're down to words, and words are a parent of a character. So that whole hierarchy of objects, it's saved in that form because we don't need another form. So this is the one you probably want for like save buttons in your software. Like we don't need fancy Unicode human readable stuff because this is just going to go to that file. And when anybody clicks open it, it's going to open with our software and go. So it needs to be back in that object form. So this is what we would use to send our own custom objects to a file for like a save button. Again, object input stream, and then into the constructor, we pass a file object where we want to send it to. What else do I have in the notes? Oh, input streams. I'll write this in another color. Input streams. Input objects. So remember to cast them. So whatever it is, if you store some numbers, it's not going to bring back an integer object. It's going to bring back the object. So you need to cast that into an integer. Or whatever you're saying. What are we looking at class? So animal object. We need to cast that into an animal or cast that into a okay, so, sorry, I paused in the chat room. What do we look at class? So if we stored it in a file, our input streams can bring back objects. We need to cast that animal or vehicle or shapes. We might look at shapes. I know shapes were in the homework. We didn't look at it in class. some of our standard examples, we have to turn it back into the object we actually want because those have to be made in the most generic form. Or you could extend it and make a custom subclass of it that does return the type of object you want, if you know what it's going to be, because that would be one method added, so it's not going to be hard to make that class, right? Anything else? Just serialization. Looks like I'm out of room on the board, but in order to write a file, we have to make it serializable. Serialized as in serial and parallel. Remember those words, like serial wires. All right, 5 of them. For serial communication, we send all of the bits on one wire, like USB. The S stands for serial. Whereas if we open it up and open the computer up and look at the motherboard, there's the main bus running through there. On most modern machines, it's going to be a 64-channel bus, so we send 64 bits at once. So to send that same data serial or parallel, what did I write? 5. We would have 5 different channels and send all of the bits at once. So serial and parallel like that, because it's kind of hard to write this to a file. We have to know exactly what's going on, where each one is coming from, which is the highest bit, which is the lowest bit. We'd have to know extra information. So we have to make sure it's in serial form, which in general is only going to show up when we get to parallel processing, which we have to write our own streams in order to use parallel processors. So we'll see that in week 8. So serialization is the word that means write an object to storage, and deserialization writes storage to an object. I put those on the word somewhere. So input and output are what they chose for the object names here. So our output from the code to the file is serialization. And from the file to the code is deserialization. Hopefully y'all probably figured out pretty quick that if I made it a point to write those words down, you're going to see them on a quiz pretty soon. So serialization goes from object to storage, or from program to hard drive. Deserialization is bringing it back in. And in order to do that, we have to implement the serializable interface. But we did that in an earlier example, previewing it. So yeah, I'll put it over here. Must implement serializable interface. And there are more. There are many, many, many more ways to input and output streams. I believe our textbook likes to spend a while with the data input and output streams. It's going to be very much like a file input and output streams. So we'll see that in the book. In general, they're often mostly interchangeable. It's just some are better in other situations than others. So really the difference comes down to when you're on a big, huge project at some point in the future when you're not under tight time constraints like a classroom, and you're looking to optimize it, and you read through the documentation on every single one to figure out which one is best for your particular situation. So the main takeaway is that there are lots of ways to do it. This is the quick way that's going to show up in class examples. These are the 2 better ways that you're probably going to want to use in your homework when you have more time than we do in class. Which I guess is a good time for class example, right? Which this will go quick because there's nothing fancy in the syntax. We've already seen all the syntax to it. The main thing, and any IDE will let us know that we can't do this part without wrapping it in a try catch block. So I'll create a new file or a new project. I'll just do an AMP project. File IO. Sounds like a good name for it. Get all this stuff out of the way because comments are just clutter for classroom examples. In main, that way I don't lose track of these. In file IO files. But it is usually a good idea to label the closing curly braces. It's easy to get lost in closing curly braces. Lose track of them. I guess to start with is a basic text file. String, I'll just call it S1 because nothing's really popping in my mind. I'll make that a new string with here's some data to write to a text file. Guess I'm not feeling super creative tonight, but just a basic example. We know how to create strings. Could do it without this part, but sometimes there are advantages to doing it that way. Not in this case. This is not one of those cases where there are advantages to do it this way. That way, I just kind of did it that way. Because if we put E is assigned a string, it doesn't take any thought to figure out what constructor goes there, right? The sort of thing a computer or a compiler will automatically do for us. So sometimes there's advantages, but in this case, there's not. And we need to send that to a file. So I'll create a new file object. I'll call it string file because there's going to be a couple of file objects in this example. That'll be a new file. And I'll call it random string.txt. One part to kind of show you where it goes. Okay, then the imports. It's only been a week since I used NetBeans. I had to think really hard about that keyboard shortcut. Y'all have probably seen that by now, right? As you use different softwares, different editors, go back and forth between them sometimes. They start to blend together. Languages start to blend together when you're writing Java code and start typing Python. I'm guessing everybody in here has seen that at least once by now, right? Or something else. It's even worse when the languages are close. We'll be writing C# and start writing Java. That one's really confusing because they're just small changes. C# is one of the worst ones because string is lowercase in C#. C# counts strings as primitive data. So if you start writing Java code, you have to go back and find every place you throw a capital S on the string. Or vice versa. So we have our file and we need to send that, well, write it. So to write it, read it, we need a scanner, which should make sense. And to write it, we need a print writer. I don't know why I wrote object on the board. It's print writer. A print writer object. Object is not in the name of that. If you want to take a second and erase that from your notes, did not mean to do that, but we need a print writer. I'll just call it writer. Is a new print writer. And after importing that, should get a message that can't do an empty constructor. So a print writer has to know what file it's writing to. or string. It has to know where it's writing it. And one more error message here to deal with. A print writer can throw an IO exception, so we cannot create one without handling that exception. I'm not sure the keyboard shortcut, but if it's for that issue, you can click on the light bulb. There's got to be a keyboard shortcut, and the second option, surround with a try catch. Or you can type the try catch block if you want to just get some more practice doing the Java syntax thing. Oh, and what it did by default is a very useful one. Apparently NetBeans, wherever they set that up, the people at Apache decided that a great thing to do with the file IO exception is write it to a log. So notice there's a logger.getLogger object that can access some sort of file name. Well, they wrote it in a really complicated way. They wrote it in a works everywhere situation, but logger.getLog just needs a file. So if you know what your log is, you just put errorlog.txt. Might make more sense there. Or even better form, new file is errorlog.txt and log that file, or I'll just do a standard out. File not found. They took it up a step. IO exception is a child of file not found, so it will work with that. A child will throw its parent exception. We saw that the other day, right? So they went up a step, and file not found will work on both of them. But a print writer is usually an IO exception because we can also feed our streams into a print writer. It doesn't have to go to a file. It can go across the network or anywhere we want to send it. And then here in the try catch block, there's a couple other things we need to do. I delayed that in case anybody just wanted to manually type it. But most IDEs will have a similar thing like that, where you can automatically throw in those exception handling, the required ones. And the print writer, a nice thing about that, reasons a lot of people use it, even places where there would be something better than a print writer, is it has the exact same methods as the system.out. Has the exact same methods as we have on standard out. So print line, print, what do we have? Print line, print F, write, which write and print are different than each other. But it has all those same methods that we would normally be used to. Print is for text, like we're used to and what we're dealing with every time we go to the standard output. Write is for other things. So we can just use that print line. So writer is going to act exactly like system.out. Or another way to say it is system.out is a particular type of print writer object. It's a particular static instance of a print writer. So writer dot, and you'll see a bunch of stuff here that looks familiar. Flush, I don't think we've used that much. Clear what's there, can be useful. Format things, bunch of prints, print F, print line, those are the ones we probably want. So I'll do print line and print string file. Run it and see what happens. Okay, no output. I guess the only thing that there was to output to the console was an error message, so that's a good sign. Does anybody remember where it goes if all we do is a relative address with no other path information on it? We'll see it before I get to anywhere to point at. If I go in the project for it, it's right here at the top level. Because our source code is here in the source file folder, and our compiled versions are over here. So when it's ambiguous as to where that's going to write it, is it going to write to the spot where the compiled versions are? Because then it's way out of place, because the only thing that should be in that folder is compiled executable file, executable code. Should it go back to the source folder? So that could also be ambiguous, because the source folder could be moved without impacting the compiled versions whatsoever. So most of our packaging, it will go up to the top level. So Ant, Maven, Gradle, that it defaults up to the top level. That's usually not where we want it. So you almost always want to be explicit where you're sending. So that's just a matter of typing in the file path. Everybody knows how to do that, right? C drive, the users folder, the username as a document, and send it there. So just typing in a full path so to make sure it goes exactly where you want it every time. I'm going to kind of skip that for this example, because you all know how to. Hopefully, everybody's familiar with the file things. I mostly wanted to point out where it goes if you don't do that, because as far as homework, this is a great spot for homework to go to, right? Because then it's in the project file, and you can zip up your out when you zip the folder and submit it, or upload it. When you upload it to GitHub, it's right there with the rest of the files. Oh, something seems missing. There's no words there. That is a manually hard-coded in error that is standard across our programming languages. Anybody seen it before? You know what caused that? It's manually hard-coded into pretty much every programming language. They decided that would make a good standard. We didn't get any error messages. It created the file, created it fine. It says it wrote the file, but there's nothing showing up in the file. Does anybody know where that is coming from? Oh, I'm at half. Whoops. I don't have any place left to grab it. Gotta do it this way. Oh. There we go. Half the screen. Y'all have done this before, right? Okay, something's wrong with the code. Need to change, make some changes, and start typing. Oh, I'm not changing the code there, am I? Everybody's done that before, right? But we're humans, we're intelligent. We will notice that. We will notice that that cursor is in the wrong spot. A computer is not intelligent. It will never notice that. So wherever the focus is, the computer is going to work there. And it's never going to notice it. And that can be very destructive at times. So our standard hard-coded in error to prevent that from, try and prevent that from happening is to, if we forget to close the file, nothing shows up. How about some guesses? Do we need to close the file or the writer? It's only going to take 30 seconds to try them both, right? Somebody tell me what to try first. Writer? That makes sense. Oh, the predictive text says writer has a method, a close method. Whoops. I guess we can look at this way as well. Whoops. What's the file? String file. And if I type C, it looks like there's no close on the predictive text. But again, that whole learning process, informal approach to the scientific method, right? I'm going to close this. So we saw that if the file's there, it creates it, but I'll go ahead and delete that first one. The print writer is the handler. So that's what we have to close. And then our file object is still around to use somewhere else. So run that, no error messages. Check the folder, it looks like it created a new one. Only this time it doesn't say 0 kilobytes, we might look at that. That's sort of a standard across the board in programming languages. They went ahead and hard coded that in. If there's no error messages, it looks like everything worked, but something didn't come through, then we have a problem. Oh, it looks like I printed the wrong thing. I printed the file name. Like I didn't mean to print the file name. So let's go back here, fix that real quick. Oh, so we shouldn't print line string file, we should print line S1, the string we want to end up in that file. So if it already exists, it creates it. I'll do this. And when I go open the file, any guesses? Do you think it overwrote the file or appended to it? It obviously didn't delete the file. Because we didn't specify anything about appending. So write line was kind of like our console, right? Whenever we run the program again, it deletes what's there. So it is an overwrite. And you'll notice right there at the top of the predicted text is append is something specific. So print is an overwrite and append is append. Unlike the language you would have seen in the two prerequisites to this, where we use the same words, but we pass in a different parameter. For Java, we have different methods. So that's a basic text file. The file input output stream is going to be very, very similar. It does it 8 bits at a time. Object output stream. I think I want to look at a buffered stream. So there's still a couple more things I want to look at. So probably a good time to take a break, and then we'll look at these better versions, and then quickly look at servlets tonight, as well as a buffered output stream, because, well, the thing I made a big deal about, the one we're going to want to watch, that was a print writer, so we know that's moving our data 16 bits at a time. Works fine if our data is Unicode. But what if we're doing like an astronomy database? We're going to have a bunch of astronomical numbers. Pretty much everything's going to be long data. 16 bits doesn't necessarily work out so well for if we know our data is all in 64 bits. 8 bits doesn't really either if we know what our data size is. So there's a way we get more control as well. Well, I want to look at that this evening because I don't think our textbook does a good job explaining it. They say it exists and then they talk more about data object streams. Might even use it without really explaining it, but it's probably a good time for a break because we're at a nice little pause point before we get to the better methods. That's the simple methods, the scanner and print writer, and that's what our classroom examples can use. That's roughly equivalent to what you have done in previous classes and the prereqs for this. So after the break, let's look at some better ones. Does 10 minutes sound good to everybody? I see head nods in the class here. Let's see, my laptop says 7 o'clock, so we'll get back to it at 7:10. I'll see you in a moment.